So, hi everyone. Welcome to the second webinar on a series of 3 different webinars organized by the FNQLSDI. So, the first webinar was actually on hydrogeology. The webinar of today is going to be on environmental site assessments, and the third webinar will be more precisely on environmental sampling. My name is Claudel Babineau-Boulé, and I will be the one giving you the webinar today. And then if you have any question regarding the subject or any related subject or anything, feel free to send me an email or call me at the FNQLSDI. You'll find all the information on the last slide. Why should you follow this webinar? First, it might help you understand what consultants do. So if the band council has to hire a consultant for any environmental reason, maybe this webinar can help you understand a report that would be on environmental site assessment. Again, it can help you understand the main step of environmental site assessments, and it could also be to refresh or reinforce current knowledge you have or personal curiosity on the subject. But to whom is this addressed? If you are an expert working in the environmental field in environmental characterization since 1999, I'm telling you this is not for you. Today we're just going to go with the basic notions to make sure people understand the big and the larger concept and the larger ideas of what is environmental site assessments. The webinar will be divided into 4 different chapters. The first one will be a brief overview of how the management of contaminated site is done in Quebec and in Canada. The second one will be on contaminants and the different sources of contamination. The third chapter will be directly on the reports and the studies of environmental site assessments and also site remediation. And then the final and fourth chapter will be on available tools and online guides. Managing contaminated sites in Quebec and in Canada. What is really important to understand here before we really start to go deeper into the subject is that there is a difference between Crown lands and traditional territory, because you have the Quebec approach with contaminated sites and you have the Canadian approach with contaminated sites. So 2 different approaches. So depending if you're on Quebec land or on Crown land, it's going to be a little bit different. Globally here, what you need to understand is that there is one approach for the federal government and there is one approach for the provincial government. So depending if you are located on Crown land or on a provincial land, you will refer to different approaches or different regulations. So for the global approach, the federal approach was put in place in 1999 and is based on a 10-step process. And there is an action plan which is called the Federal Contaminated Sites Action Plan. And this plan is actually taking care of different contaminated sites, but only on Crown lands. And globally for the guidelines and the different soil criteria that you need to take into account when you work with the federal is mostly based on the Canadian Environmental Quality Guidelines of the Canadian Council of Ministers of the Environment. For the provincial area, you had in 1988 a land rehabilitation policy that was then changed in 1998 for soil protection and contaminated sites rehabilitation policy. And then in 2016 there was a new guide which is very helpful. You can actually have a lot of information in that guide, which is called the Intervention Guide on the Soil Protection and Contaminated Sites Rehabilitation Policy. There is also an action plan which is different on the provincial side. And if you look at the different criteria for the soil, to know if the soil is contaminated or not, you have to check the generic criteria of contaminated soils developed by the Ministère de l'Environnement et de lutte contre les changements climatiques. Regarding the federal contaminated site decision-making framework, so the 10-step process that we were just talking about, well, this actually happens when these are all the steps from day one that you're suspicious about one site until the day that the site is going to be cleaned up, and then there's going to be a follow-up about the site, and it's going to be monitored, and everything's going to be fine about that site. So step one is to identify the suspect site. Then the second step is about doing the historical review of that site. Then you start the initial testing program, which is step 3. Step 4 is to classify a contaminated site using the CCME National Classification System. Then you go for the detailed testing program. Then you will follow with step 6, which is to reclassify the site using CCME National Classification System. Again, you can find online all this information. Then step 7 is to develop remediation or the risk management strategy. Then you have the implementation of the remediation or risk management strategy. Then step 9 is the confirmatory sampling and final report. And finally, step 10 is the long-term monitoring when it's needed. All these different steps are actually pretty much the same that the phase 1, phase 2, phase 3, and remediation and risk management that you will find on the provincial side, but we will talk about it a lot more later on. It is important to understand that we don't want you to become lawyers with this specific slide. It's only just to give you an idea that depending if you're located on federal land or provincial land, it's going to be different legal applications, so different regulation, different policies. So for the federal side, you can actually have a few laws such as the Canadian Environmental Protection Act, Fisheries Act, Canadian Environmental Assessment Act, and then on the provincial side, you're gonna have again the policy that we were talking about, the soil protection and remediation of contaminated land policy. You of course have the Environmental Quality Act, which is really important, and other regulation that you can look into if you are interested in the subject. Chapter 2, Contaminants and Sources of Contamination. What are contaminants in general? Well, actually you have different kind of contaminants. You can find organic contaminants, you can find inorganic contaminants, and you can find a lot of other kind of contaminants such as radioactives or viruses, bacteria, biological contaminants. For today, we're only going to focus on organic and inorganic contaminants. So to give you a few examples of what is an organic contaminant, you can find hydrocarbons, pesticides, solvents, and more. And inorganic are mostly, not only, but mostly metals. Of course, contaminants have different effects on human health, so that's why it's important to have a look at the soils to see if the soil or groundwater could be contaminated. So if you want to have a brief idea of different effects that you can actually have from different contaminants, you can have a look on human health and also on the wildlife. So on human health, organic contaminant can be carcinogens. They can also provoke different skin problems or chloracne. Then inorganics can also give you cancer again, and can develop many different type of health issues such as liver and kidney problems, different problems to the nervous system, decrease in bone density. So there are really bad human health effects that can be associated with different contaminants. Same thing on the wildlife. You can have very bad effects on reproduction, growth, behavior. You can have bioaccumulation in vital organs such with mercury or PCBs. And worst case scenario, some contaminants can also lead to mortality. What are the different contamination sources activities that could maybe create a potential risk to the environment? or just create a source of contamination? Well, any industrial activities could be a potential source of contamination. Any commercial activity as well, even more if they use chemical products, a gas station for instance. Then any sudden or long-term leakage, maybe you have an above ground tank with stove oil in it, and maybe there's a small leakage, but after 10 years where the contamination will be more important in the soil. Then you can also have maybe an accidental spillage, fire, the disposal of different products. You also have to take into consideration that migration of a contaminant from maybe a neighboring site could also be a source of contamination. For instance, your neighbor is a gas station and had problem with one of their tank. Maybe you're gonna be the one having the problem with the contamination because of its migration. Also, you have different problems of intentional contaminant release, such as illegal dumping, that could be a source of contamination, and etc. Sometimes a case study or a case example could be a very good way to understand a problem. So we will talk about a famous case that happened in Shannon, not far from here in Wendake. The case, actually in 2000, after the analysis of the city's groundwater, the municipality of Shannon found that it was contaminated by trichloroethylene. This chemical product was used by the forces on the military base in Valcartier to clean the weaponry. This contamination would later be linked to an increase in cancer diagnosis in the area all the way to Val-Belair. There is still an ongoing debate today to understand if the contamination and the cancer is really related, but there are a lot of reports that you can actually look online. There is one from Radio-Canada, the show Enquête. You have one that was in 2009 and another one in 2017. So you can have a look, click on the link, and go watch these two videos or two shows online. They're really interesting. And you can sometimes understand how a small thing that is happening every year after year can eventually become a huge problem. So what happened there is that because of the army was using this product to clean all the weaponry, eventually it went in the soil and eventually it contaminated groundwater, and then people were actually using this groundwater as drinkable water. So it eventually became a huge problem. So if you want to have more information on that specific case, go watch online the two videos that are on the page, and if you have any other question, feel free to contact me again. What are the most common contaminants? Actually, the most common contaminants that you can find maybe in your community could be petroleum hydrocarbons, because if we think of heating oil, if you think of gasoline, if you think of diesel, well, in any community you have a gas station, you have heating oil for different houses. You can also have a dump and you have a problem of incomplete combustion, or maybe a house that's gonna burn, then it could actually affect or impact the soils. And another one that is pretty common is used oils. If you think of a mechanical garage, any community has at least one, so think about it, because these are a different contaminant that could really impact the soil. Another type of common contaminant are organochlorines or solvents. For example, you can find perchloroethylene, which is organochlorines, and dry cleaners. Actually, in their cleaning machine, they used to have an open circuit, so if they would have a leakage or something that would go in the soils, that could contaminate the soils. So former dry cleaners, well, the one that were opened before 2000 more or less, could actually represent a risk for the environment because of the perchloroethylene that they were using back then. And then you can also find polychlorinated biphenyls, or also called BPCs, in old transformer, for instance, old transformer from Hydro-Quebec or other transformer, the oil they were using back then was with PCBs, and that could also represent a major risk for the environment. Another very common contaminant are metals. For instance, in car batteries you can find metals, you can find lead. In any electronic appliances and their components you can find different kind of metals as well. In the former paint they were using in houses or wherever they were lead-based paint. And again, in any chemical or any industry, there's always a process that's going to use metal and can eventually impact the soils with that contamination. Here, a case study which is very interesting to give you an idea how just a regular tank can actually become a real big problem. So this is a story that happened in Obidjwan, and we call it the Green Quadruplex. And I would like to thank Marie-Soleil Wezino. She's the one who gave us all this information. So if you have any question, she works for the band council in Obidjwan, or you can also send me an email and I can try to answer your question. But globally what happened is that there was groundwater contamination because of an heating oil system. So in 2008, when they were doing some work near a reservoir, near a tank, they realized that there was a spill that was estimated at 8,000 liters that was actually missing in the tank. So they did an environmental characterization of the soil and groundwater, and they realized that they had so far 615 cubic meters of contaminated soil to a depth of 6 meters. And that was very close to a well that was a well that was supplying for drinkable water to the community. So first, they tend to relocate the drinking water well, and they couldn't, so they closed it. So the community still had another well to use, but there was still the problem of contamination not so far from the well. So they had to remediate the entire site. But sometimes even if you want to remediate, it takes a few years before you get the financing, the money to do it, because it's very expensive. So by the time in 2010 the groundwater sampling demonstrated that there was a migration of the contamination. So now you had even more contaminated soils. You had 1,875 cubic meters of contaminated soils to a depth of 8 meters. So in 2011 they started the remediation, but in the end it was cheaper to relocate the quadruplex because the contamination was under the building. So that was cheaper to just relocate the quadruplex. So you can imagine how expensive it is to remediate. During that time, you remember that one of the well was contaminated, so they installed a charcoal filtration system on the well because they had to reopen it. And that filtration system did work very well, so now they can use again all that the water from the well. Since then, they've been doing monitoring on the groundwater quality to make sure there is no other concentration problem of hydrocarbons in the groundwater. And so far, the groundwater is always the quality of the groundwater is always below the recommended criteria. But that was just to give you an idea of how maybe just a hydrocarbon, like a oil tank, with just like a small problem when it's in its pipes, for instance, can create like a huge problem. So that was just to give an idea. Chapter 3, which is about environmental site assessment, is actually the main chapter of the webinar because we're going to go a bit deeper into each step of the environmental site assessments. Phase 1, Phase 2, Phase 3, and remediation. So what is an environmental site assessment? Of course, we will go deeper into the subject and it will describe every step of it. But to start, maybe if we can have like a general definition. This one is from the Association Québécoise de Vérification Environnementale from Quebec. So here is the definition: a systematic process with which an assessor investigates if there is a risk of potential or actual contamination on a property. The assessor analyzes the past and current activities which have occurred at the site in order to measure if those activities have an environmental impact on the site. When needed, the environmental assessor will sample the soil, the groundwater, and other elements such as air, isolating material, etc., in order to conclude if the site and or the building is contaminated or not. The ESA consists of 4 steps: phase 1, phase 2, phase 3, and remediation. So this is just a global definition. So now let's go have a look for each step of the assessment. So the first step of ASA, so an environmental site assessment, is called the phase 1. The phase 1 is an historical review of the site and the surrounding of the site. But globally, what is the goal of the phase 1 is to detect any signs of actual or potential contamination at the site. And you have 4 main components in the phase 1. So the first one is usually the study and the historical review. Then you're going to have a site visit and an interview with someone who knows the site very well. And then eventually you're going to have to analyze all the data that you're going to collect and then write a report. So that's going to be the main components of the phase 1. And eventually the purpose is to determine if there is an activity at the site or around the site that represents a risk of contamination to the property under study. And then you're going to be able to target the area potentially contaminated and the different source of contamination. So we were mentioning 4 different components for phase 1. The first one is the historical review, and the historical review is actually really important because it kind of gives you a better idea of what happened at the site in the past and at the current moment. Globally, you're going to be looking at all the existing files that could actually have a bit of information about the site. So, for instance, you're going to have to take a look at the title deeds, and then you'll be able to establish a list of all the previous owners or the tenants of the site. You're going to have a look at aerial photographs because you can find photographs dating for maybe more than 100 years ago, so you can see if there was an evolution at the site, different buildings, demolitions. You can also actually you have to send a request to all ministries. We call it access to information request, and you ask them if they have any environmental reports or files or information about the site, and then they have to send it to you if they have it. Then you need to take a look at all the different registries, so the inventory of contaminated sites or the inventory of soil and industrial waste disposal sites from the provincial government. Then you also have a federal contaminated site inventory that you need to look at. Then you also have Urgence Environnement Response Registry that you can have a look at. Eventually also the groundwater information system, which is also available online. You have the Régie du Bâtiment du Québec. You have all the fire insurance plans. Any previous reports could have a lot of information for the site, and eventually all the topographic, geological, hydrogeological, and soil maps that you can find regarding the site. So all the data that you're going to collect in the historical review will give you, of course, a better idea of what happened at the site. But then the second step, or second and third step, you have to take is the interview and the site inspection. So you need to find someone that is familiar with the site. So it could be maybe a tenant, it could be a former owner, it could be maybe the neighbor, it could be someone that works at the site. So anyone that knows the site. And then you're going to go around the site with that person and you're going to ask a lot of questions. So globally, you're doing like a little inquiry about what happened at the site, if there's any suspicious thing on the site, And a few elements that you really need to take a look at are, for instance, any specific products on the site, any storage, any spots on the floor. Maybe there could be oil on the floor. Then the heating and the cooling system. Is the heating system an old one using stove oil, or is it a new one with electricity? You're gonna have to take a look at the drains and sumps, the sump pump, and see if there is maybe a smell or weird color. And of course, you're gonna have a look at the nature of activities. So what is happening at the site? Is it like a gas station? Is it a kindergarten? And this could give you a better idea of if there is a risk or not of contamination at the site. Again, you're gonna see if there is the presence of backfill at the site, looking at the topography and the surrounding area. And you just need to look for any other element that could indicate the presence of potential or actual contamination. So here are a few indicators that you can look at during the visit. So you see on the first picture, you have drums and you see spots on the floor. There is no concrete slab, so that could actually be a huge risk of contamination, because we see there's probably fuel in those drums and there's nothing to protect the soil. So if there is a leakage, it could contaminate the soil. So this is a risk. Then on the second picture on the right, you see vent and filling pipes. Vent and filling pipes are always linked to a tank, so maybe that's a sign of a oil heating system. So you need to have a look at that, and that could also represent a risk. And on the third picture at the bottom of the slide, you see backfill. Doesn't look too clean. There's stuff in it. So where does that come from? So we need more information. So that could definitely be a risk for the site. So globally, during the visit, you look at what could be potential risks, and you ask questions with the person that who knows the site about any activities, any problem that could have occurred at the site. The fourth component of the phase 1 is actually the report that will include all the analysis of the different information that you have been collecting so far. Again, the Canadian Standard Association has a few sections that they want to see in a phase 1 report. So you need to find a table of content. You need to find the introduction, the description of the site, file review, site visit, an interview, the result, the assessment of the results, and then a conclusion. But globally, the report is important, because this is where you're going to decide and say if there is a phase 2 that is recommended, or if there is no further environmental study that is recommended. So globally, you take all the information that you found so far, and if there is any risk, well, it doesn't mean that it's contaminated, but if there is a risk, you're gonna need to go for a phase 2. And if you haven't found any risk, well, then it could be the end of the assessment. So 2 different conclusions in a report of phase 1. You can say that the study has revealed no evidence of potential and or actual risk of contamination in connection with the site under study, so that no further environmental study is recommended at this time. Or you can also mention that the study has revealed evidence of potential and or actual risk of contamination, and then you will have to recommend a phase 2. And now we will see what is a phase 2. When the phase 1 recommends a phase 2, well, then you have to make a phase 2. So what is the goal of the phase 2? What's important to understand is in the phase 1, there was no sampling. It was only about looking at the site, looking at the history of the site. But then when you go with the phase 2, you're going to have to go and take a few samples at the site. So we call it the preliminary characterization, or the initial testing program. So the main goal of the phase 2 is to determine the presence and degree of contamination in the environment. And of course, it follows the ESA phase 1 that we just talked about. Again, you're going to have 4 different components in the phase 2. The first one is planning the sampling program. The second component is the field work. Then you're gonna need to analyze the samples, and eventually you're gonna do some data interpretation, and again a report to have a conclusion, to make conclusion about the information you've collected so far. As we were saying, there are different components to phase 2, and the first one is the planification of the sampling program. This step is very important because it's going to help you to arrive to the site well prepared and with all the good material. So before you go at the site, you need to develop the sampling program, and to develop it, you need to think about what are the different risks. So then you can choose what are the parameters you're going to analyze, so what kind of bottles you need to bring to the site. Also need to decide what kind of sampling technique you're going to use. Are you going to drill boreholes? Are you going to go with backhoe? Are you going to do trenches? Etc. So you need to take all this information into account and then make a map of the site, so the person that's going to go to the site is going to know exactly what he needs to do at the site. The second component of the phase 2 is of course the field work. But before you start drilling, you need to think about the presence of underground infrastructures. So maybe there is a former underground tank, so you want to make sure you won't break it when you start to drill. Then you need to do all the sampling work according to the program you have. So drill the different boreholes or the different trenches and take the different sample you need. You always need to clean the instrument before all the use of the instrument, and you need to take notes of everything. When you're on site, it's very important to take notes about about the soil, about the weather. You take pictures. You want to really have a lot of information for the person that's gonna analyze the sample and the field work that was done. After the field work, you'll go back to your office with all the samples, but you won't send all the samples because it's going to be very expensive if you do that. So you need to choose what samples are the most representative of what you have on the site. So you chose those different samples, you send them to the lab, and you know that the lab you're gonna chose the lab you need before you go at the site, just because you're going to order the different bottles to sample at the site, and then you send the chosen samples to the lab. Again, the fourth component of the phase 2 is the same that for the phase 1. You're going to take all your datas and you're going to write a report with that. So in the report, you need to assess all the results, you need to do the report, and of course you need to bring conclusions. So you have 3 potential conclusions when you write a phase 2, and the first one is maybe no contamination found. So if you send samples, there was no smell, then you send it to the lab, there is no metal, there is no hydrocarbon, there's nothing that you've been analyzing, so there's no contamination found. It could be also you found a bit of contamination and you need more information, so you're going to recommend a phase 3. This is usually what happens. Or maybe a very, very small problem, it's only a small thing that you know that has been leaking, but not for a very long time. Maybe you're just going to recommend directly a remediation, or maybe eventually a risk assessment or risk management, but we're going to talk about it a bit later. If the phase 2 recommends a phase 3, then you're going to start a phase 3, which is a detailed testing program. The goal of the phase 3 is actually to obtain more information in order to complete the missing information in the phase 2. So the study enables to better define the nature, the extent, and specific location of the contamination in order to establish the potential cost of the remediation or risk management. So globally, the phase 3 is is used to complete the information, all the missing information that you could have for phase 2. So if for instance you find in phase 2 that there is a bit of contamination somewhere, but you don't know where it starts or where it ends, well, the phase 3 is going to help you to better define and locate all where is the contamination. Again, you have the same components that you can find in the phase 2 in the phase 3. So you have the planning, the planification of the sampling program, you have the field work, you have the analyzing of the samples, and then the data interpretation, and finally the report. When after the phase 2 or the phase 3, you know that you have a problem of contamination, you are now at the step of the remediation. You can actually remediate, or you can also do some risk management. For the remediation, the goal is to reduce the risk related to the contamination and to respect the applicable regulations and recommendations. So you have different options. You can remediate, you can confine, or you can stabilize the contamination, but mostly you have 4 components in the remediation process. First, you need to define the goals of the remediation. Then you need to select a technique. Then you need to ask for authorization if required. And then you can do the remediation and the follow-up and reporting. There are many techniques of remediation. The first one is the in situ intervention. This one means that you're gonna work directly on the site and you won't move the contamination from the soil, from the ground. It's gonna stay there, and then you're gonna work with maybe a pump or injection wells, or you have a different type of intervention. You can also have an ex situ intervention. That means that you're going to excavate the contaminated soils, but you're going to work with them and you're going to remediate the problem directly on the site. Or there is also the off-site management. So you excavate the soil and you bring them to an authorized place where they're going to take care of the problem of the contamination of the soil. So you have also different methods of treatment. You have the chemical and physical one. You can have a thermal method, and you can have a biological method. So the first one, chemical and physical, it represents the most diverse group of remediation technologies because it can include soil vapor extraction, solidification, stabilization, soil flushing. So there are really a lot of different methods. Then you have the thermal one. It generally involves the destruction or removal of contaminants through exposure to high temperature in treatment cells. And you also have the biological one that uses a microorganism to degrade organic contaminants in soil, groundwater, sludge, and solids. There is also an alternative to remediation, and it's called risk management. Risk management consists of removing the exposure to the contamination, but with the risk management, the contamination can actually stay in place. You cannot use that technique all the time. It depends on the contaminants, and in order to determine if you can do or not do a risk management, you need to do a toxicological and an ecotoxicological study. And these studies will study the receptors, so human, wildlife, and see if the contamination can impact them. If they are not really impacted, then eventually we're going to be able to do a risk management. It also depends on the regulation. So sometimes in certain places you can, others you can't. And also, as I was saying, it depends on the contaminant. You can use risk management sometimes when it's very expensive to remediate, so when the remediation costs are too high. Sometimes it's because you have a technical constraint to the site. For instance, if you have contamination under a building, you cannot reach it, but in the end it won't affect or impact any person or anything, so maybe there's a way the contamination could stay there. But again, you have to study every case to see if there is a risk management possibility. And what is an advantage of the risk management, it's usually lower cost, and it allows you to use different sites that would not be used otherwise, and you can so you can recover different contaminated sites and use them to do something else. We're gonna now go for the fourth and final chapter. I'm just gonna give you a few available tools that are online and guides also available online. So here you find different documents. You have the CCME documents. The first one, you will have all the information on that website from the CCME. Then the following documents, the guide de caractérisation des terrains, guide d'échantillonnage à des fins d'analyse environnementale, and the guide d'intervention are provincial documents. And then the last one is the CSA standards that I was talking about for the phase 1 and the phase 2. They're usually around $100 each if you want to buy them online. Two other very interesting tools that you can find online. The first one is the federal contaminated site inventory, and the second one is the provincial one. So if you start with the first one, it's very interesting because you can know where are located all the contaminated sites that are inventoried online, and so you can use actually a map and just travel around Canada and see if, for instance, in your community there is one contaminated site, or maybe a site that is that was remediated. So you will find all the information about the different sites. And then again, you have another one which is called the Répertoire des terrains contaminés. This one is provincial. So it's a tool. You go online on the website, you can enter the name of the community, you can write an address, or you can just put a bit of information, and it will then lead you to the different contaminated site that you can have around your house, maybe in the community, near the community. Not all the sites are in those two inventories, but it can give you a good idea about the presence of any site around your community. So that was it. Now that we're done with this webinar, please note that we're gonna have a third webinar on sampling. If you have any question, you have my email right here in the slide, so you can send me an email. You can also reach me. The phone number is just there again on the slide. And if you have any question, any comment, if something wasn't clear, or if you would like to go deeper into one subject, well, feel free to call. We will be very pleased to answer you if we can. If I can't, I will find someone that will be able to answer your question. So thank you very much, and I hope you will watch the third webinar as well.